Okay, folks, we're at limits at infinity 4. Page 1 is simply a compilation of what I've taught you in videos 1, 2, and 3. So I'm not going to do any examples. We're going to go straight to page 2 and problems 16 through 18. When I go and I substitute positive infinity in, I end up with positive infinity and a negative infinity, which is another indeterminate. And what we find out with this particular indeterminate form is your answer can be plus or minus infinity. It can also be any positive or negative number, and it can be 0. I will do one of each case. So for our first one, like all good problems that have these radicals in them, I need a common denominator, and I'm going to rationalize. So I went ahead and rationalized, and then I simplified. X squared minus x squared leaves me with just 9. And now at this point, I'm going to use my end behavior for the square root of x squared, and the end behavior for the square root of x squared plus 9 is the square root of x squared. But x is going to a positive infinity, which means x is greater than 0. So the square root of x squared is the absolute value of x, which in this case, since it's positive, is what you see is what you get. So I simply say, oh, the square root of x squared is x, and x plus x is 2x, and 9 over infinity is 0. Case 1. Case 2. The limit as x approaches positive infinity of this particular one, again, is a positive infinity and a negative infinity. So I need to do more algebra. And when I come back over here, I have to put the 1 in the denominator. I have to rationalize the numerator. And x squared plus 3x minus x squared, the x squareds cancel. I'm left with 3x. And again, I'm going to have to go to my end behavior model. And the square root of x squared plus 3x, the highest degree, would be the square root of x squared. But x is greater than positive infinity. And x is going to a positive infinity, so x is greater than 0. So once again, the square root of x squared, which is the absolute value of x, will be the same as x. But now x plus x is 2x. But look, the x's cancel, and I'm left with 3 halves. So my limit is simply a positive number. Now, I could have made it a negative number, folks, but I chose just to go positive. And so now we're going to do the limit as x approaches positive infinity. Again, we get positive infinity and a negative infinity, which means we have to do more algebra. And so the limit as x approaches positive infinity, I insert my 1. I'm going to go ahead and rationalize my numerator. Now, in this case, when I combine the 5x squared and the negative 9x squared, it's negative 4x squared plus x. And now I'm ready for my end behavior approximation. So I'm going to use negative 4x squared, and the highest degree here is the square root of 5x squared. But once again, x is approaching positive infinity, which states that x is greater than 0. So the square root of 5x squared is the absolute value of square root 5 times x is square root 5x. So I substitute it. I combine terms. But now, the degree of the numerator is greater than the denominator. X's are positive, so negative times positive times positive leaves me with the negative infinity. Now, the rest of the sheet is about vertical, horizontal, and slant asymptotes wherever they exist. And I'm going to cover an example of each type, not necessarily in order. So let's just go back and review what we've done already. So when I look at this one, I can use my end behavior and just look at 3x over x. I don't have to say it. I can just do it in my head. What's 3x over x? It's 3 over 1. It's 3 for the horizontal. The vertical is 5. So over here, remember I want to know that these are limits. Your asymptotes are answers to limits. So the limit as x approaches 0 gives me the infinity here, so that's why it's x equals 0. And again, if I were to write this as a limit, this disappears as I approach positive or negative infinity, and y equals 4. Problem 3, without showing any work, just doing it in my head, what makes the denominator 0? X equals -5. Taking in behavior the highest degrees, dividing them, my horizontal asymptotes y equals 2. Now I could have officially done the synthetic division and put it in quotient remainder form. I mean, you want to do that, go for it, but most of us literally just use the in behavior because we're not asking you to do a proof. You only have to do a proof if there's a decision to be made, which we will talk about on another board. So I come to this one. What are my vertical asymptotes? Well, what makes the denominator 0? Plus and minus 3. And then what's my horizontal asymptote? Using in behavior, x squared over negative x squared is -1. Again, if you wanted to do long division, you could have to put it in quotient remainder form. Most of us don't do that. Once again, you do it only if you're forced into those situations. But my vertical asymptote is plus and minus 3. And I could use like the in behavior like we did up here, but I can see the quotient is -1. Now, we're moving on to the dining room. And when we get into the dining room, we're going to talk about some situations where we have to consider in behavior, and we do have to look at the actual limits. Okay. So when I do this particular problem, this is new. We've not done anything like it. So I factor my denominator. What makes the denominator 0? X equals -6 and x equals 1. And now, using in behavior, technically this is what we're supposed to have been saying for all of them. All we're doing this limit, which equals this limit, and 0 over 1 is 0. Or you could have just said, hey, look, what's the in behavior? The degree of the top is less than the bottom, y equals 0. Fine with us. Okay, for this next one, again, what makes the denominator 0? X equals plus and minus 5. And again, the degree of the numerator is less than the denominator. You could go there. You could have said, oh no, y is the limit as I go to plus and minus infinity, and looked at in behavior. And you notice that square root of x squared could be a plus or a minus x, but there's a 0 on top, so who cares? So you could have approached it this way. Again, factoring, I get x equals 2, x equals 3. The degree of the top is less. I'm done. Or looking at in behavior, I really start out with, oh, y is the limit of this. Using in behavior, which is the limit of this. Again, which is a plus or minus x, but since you're going to get 0, it doesn't matter. Now, life is becoming interesting. For this next grouping, it does matter, okay? So I say, what makes the denominator 0? Nothing. So there is no vertical asymptote. And now to decide about the horizontal asymptote. I literally have to say, or should have said, the limit as x approaches negative infinity of this, and the limit as x approaches positive infinity of this. But I didn't ask you to do a proof. I simply asked you to find the asymptotes. So, looking at in behavior, as I approach negative infinity, when this is a negative number, I take the opposite. So my in behavior is -4x over -x, which says I have a horizontal asymptote of y equals 4 as I am heading to the left. What happens as I'm heading to the right? Well, the square root of x squared is absolute x, and when it's positive, I simply keep it. And so I end up with -4x over x squared. So -4x over x is -4. And so when I go to the right, I can't cross the -4. When I go to the left, I cannot cross y equals 4. But I didn't ask you to draw it. I only asked you to find the horizontal asymptotes. Now, you might find this interesting to put it in your calculator. You will see how each of those are asymptotes at the end. And we've already done problems similar to that, if you recollect, on worksheet 1, where I had you all look at 2 different horizontal asymptotes, and it didn't matter because we were just looking at one end or another. Number 9 is similar. What makes the denominator 0, plus and minus 2? Again, I have to examine in behavior. Same scenario, a negative x here, a positive x here. And again, I come up and I'm dividing, and I get my -4 and +4. Okay, we're going to end with problems that you learned earlier on the asymptote sheet. And so what happens when the degree of the numerator is greater? And we want to know the slant asymptote. Notice it's 1 greater. We do our synthetic division. I rewrite it. And by the way, I'll hold on a second longer so you can see the synthetic division. 3 times 2 is 6, plus 0 is 6. 3 times 6 is 18. So I have y equals 2x plus 6 plus 18 over x minus 3. So the vertical asymptote is x minus 3. And our slant asymptote is y equals 2x plus 6. Again, go ahead and put that in your calculator or in Desmos and see what that cute graph looks like. So for the next one, the degree of the numerator is once again greater. So I came over and I did my synthetic division. 2 times -4 is -8, which yields a -13, which then yields a 52, which gives us a glorious 55. So my oblique asymptote, my rewrite of my f of x is y equals 2x minus 13 plus 55 over x plus 4. My vertical asymptote is x equals -4, and my slant asymptote is the quotient, y equals 2x minus 8. Now I saved Mr. Monomial for last, only because y'all seem to screw him up more than you do anything else. It's just, hey, this has been a generational problem, not just you all, over the generations. So I divide each one by x squared and get 4x minus 2 plus 6 over x squared. So I end up with a vertical asymptote of x equals 0 and a slant asymptote of y equals 4x minus 2. Now, folks, I think we are down to where we only need one more video, because there's only one problem on 5 and 6 that I have not reviewed. And can you believe it? We are almost to the end. Have a good day or night or early morning, whenever you're doing your work.